In this video, we're going to learn about our second way of computing a product between two vectors. And that's using what is known as the cross product, or it's often also referred to as the vector product. Now, why is that? That's because in this way of taking a product between these vectors or multiplying them together, the result is itself a new vector. So which is to say, if we take A, now we use a little cross multiplication sign, thus the cross product, A cross B, so these are multiplying two vectors, gives us a new vector, which I will call C. So this equals a vector as opposed to a scalar. That's why the dot product, which gives you a scalar, is sometimes called the scalar product. The cross product is sometimes called the vector product, gives you a vector. Right, so this thing on the right-hand side, which I have called C, also has direction associated with it. Okay, and just like the dot product, there are going to be two ways of computing the cross product, depending on, and which one you use depends on what information you're given. So the first one is if you're given components. Now this formula is a little long, but don't worry, I will not require you to memorize it. Again, I do not think physics is about memorization, rather it is about understanding how to appropriately apply the formulas. So A cross B is equal to AY BZ, which is the y component of A multiplied by the z component of B, minus AZBY. Now this whole thing is the x component of vector C, of the new vector. So we could even, this whole thing, sorry, that's really messy looking, is C sub x, right? And we know that because it's the term in front of the x hat. And because there's an x hat, we're reminded this thing is a vector, which, as I promised, is the case. All right, there's two more long terms that all look like this. So A sub z, B sub x minus A sub x, B sub z. This is the y hat term plus A sub x, B sub y minus A sub y, B sub x. And this is the z hat term. So this whole, let me erase this. This whole long formula is the formula for the cross product if you are given components. Now, a lot of times what will happen is that many of these components will go away because you'll have zero. So for instance, if these vectors are only in two dimensions and only have x and y components, then all of these terms with z's will all be zero. So even though it looks like a long, scary formula, a lot of the times in this class, a lot of these terms will go to zero. All right, so what about if you're given the magnitude and direction? Okay, so if we're computing A cross, not plus, A cross B, and I'm going to call this new vector C, then the magnitude of C, which is the result of the cross product, is equal to the magnitude of A times the magnitude of B times sine of the angle between them. And that's if this is A and this is B, then theta is the angle between them. Now this formula looks very similar to the dot product formula, except the big difference here is for the cross product, we have a sine of the angle between, whereas with the dot product, we had a cosine. Now this can't be the whole story, because as I said, the cross product gives you a vector, it results in a vector. And all that I've given you right here is how to compute the magnitude of that vector. So we also need to know how to compute the direction of this new vector C. And you compute that using what is known as the right-hand rule. And actually, I don't know if compute is the right word here. It's more like find the direction using the right-hand rule. Now, this is a little bit challenging to show on video, I think. But what you want to do is you want to take your right hand. It has to be your right hand. I'm sorry to the lefties out there. You need to make sure to use your right hand. And actually, to the right-handers, you need to remember whenever you do this to put your pencil down and use your right hand to do it. So what you want to do is take your hand and hold it against your piece of paper. And what you want to do is you want to move your hand such that your fingers are pointing along the first vector. And by the first vector, I mean vector A in this case, because it's A cross B. A comes first. Then what you're going to want to do is you want to curl your fingers towards the second vector being vector B. So right now, if I were to hold my hand up against my screen, I would sort of point them along A and curl them towards vector B. Now, if B was pointing more down this way, then what would I need to do? I couldn't curl them this way. I would have to flip my hand over in order to curl them towards vector B, if B was pointing down. But B is not pointing down. As I've drawn it, it's sort of pointing up. So I put my hand this way and curl it. Then the direction of C, so right now, my thumb is sort of naturally pointing sort of at me. And that's going to be the direction of the vector C. So it would be directly out of the page at me. So C, C points out of the page so that would be in the Z hat direction. So a common notation that we'll use for out of the page looks like this. So this is out of page. If it were pointing into the page, then it would look like this, into the page. Now these notations are kind of nice in case you forget whether Z is pointing out of the page or into the page for the given way you drew your coordinates. These make it always very clear when you use the right hand rule. If your thumb ends up pointing sort of up away from the page, then it's out of the page. If it's pointing into the page, then it's into the page. And the way to remember these symbols is what you do is you picture an arrow. So if an arrow is flying at you, you see the tip of the arrow, and that's the out of the page. So it's like the arrow is flying at you. Whereas if the arrow were flying away from you, you would see the feathers in the back. And so that's the sort of cross symbol. Those are representing the feathers of the thing flying away from you. All right, so these are common notations. And in this particular case, you would say C is pointing out of the page, and you could draw that. And these symbols, I put little hats on them. That's because they are unit vectors. So we can use them just like X hat, Y hat, and Z hat. And they're just telling you the directional information. All right, so that is how you compute the cross product, which again, unlike the dot product, the cross product gives you a vector. And you can compute it in two ways. The first, excuse me, is this sort of long formula where for if you're given components. And the second is sort of a two-step thing where first you compute the magnitude of the cross product. And then next you use the right-hand rule to compute the direction of the cross product. All right, that's the cross product.